So we're going to go over some of the basic information regarding chapter 15. In this chapter deals with alcohols and thiols. So just to do a quick review, an alcohol has a generic formulation of an ROH. So it's the OH, the hydroxyl group is what makes an alcohol an alcohol. And the thiol is very similar, except it's RSH. Remember, sulfur is one row below oxygen in the periodic table. So it is both a good leaving group and a good nucleophile. So you should look at the information on tables 15.1 and tables 15.2 in your textbook. 15.1 is a table that includes the reactions, the old reactions that we've already learned on how to make alcohols, whereas table 15.2 are the previous reactions that we've learned that uses alcohols. So once again, on your own, you'll want to peruse those tables and remind yourself of what we covered last semester concerning alcohols. And, of course, you should know how to name the alcohol. So, for example, remember the alcohol gets priority over alkyl halides or any alkyl group. And we're going to find out that it gets priority over anything except for things such as ketones, aldehydes, carboxylic acids, or esters. Because the more bonds a carbon makes to an oxygen atom, the higher priority it is. So in this example that I just drawn here, the alcohol gets priority in the numbering, but there's still 4, so that would be butane, because the but means 4. Except now we drop the E ending and add an OL and give it the locant, and it's be carbon number 2. So now let's go over the new ways that we're going to learn how to make an alcohol. Okay, so in general, you should think back to Gen Chem in the idea of redox reactions. In particular here, one of the new ways that we have to make an alcohol is going to be the reduction, which remember that means that the gaining of electrons, the reduction of aldehydes and ketones. I'm going to abbreviate aldehydes as ALD and ketones. Okay, and so we have to know what a reducing reagent is. And we actually did this last semester, but not with respect to alcohols. Okay, so the first thing to do with the reduction of an aldehyde or a ketone, or the simplest, is really just our good friend hydrogen. Okay, in just the generic way. So an aldehyde, and if it was a ketone, instead of the hydrogen, you would be having another R group there. So we have aldehyde or a ketone here, and our good friend hydrogen that we've seen with the reduction of alkenes. And think back to what catalyst or catalysts could be used for the hydrogenation reaction. So the most likely, the ones that are used the most are platinum or palladium. Okay, right? And you're going to end up with your alcohol. Okay, now once again, the only difference between the aldehydes and the ketones has to do with the has to do with this hydrogen. Instead of that hydrogen, if it's a ketone, it would be another carbon-containing group. Now, there is a more common form of reduction, and that's using one of the next two reducing reagents, and that's sodium borohydride and lithium aluminum hydride. So these are your hydride reagents. So we have sodium borohydride. And for sodium borohydride, you can use a polar solvent. So use a polar solvent. Or you can also look at using lithium aluminum hydride. But lithium aluminum hydride is actually stronger reducing reagent than sodium borohydride. And so with lithium aluminum hydride, you need to use something like DE, diethyl ether, or THF. Those are the best solvents to use with respect to lithium aluminum hydride. And just remember, it's a stronger reducing reagent than the sodium. Okay? So let's just do an example of this. And by the way, previous students I had used to call the lithium aluminum hydride Lyle Heifer. And so if I refer to that, use that term euphemistically, then you know that I'm referring to lithium aluminum hydride. Okay, so let's just look at an example. So this is acetone. So we have acetone here. If you use the lithium aluminum hydride, it's actually a two-step process. So we'd have our reducing reagent in DE. That's the first step. And then the second step is you need to do a hydration reaction. You just add water. And by adding water, after you've done the hydride step, here you would end up with 2-propanol, also known as isopropyl alcohol. Okay. Now, one thing to keep in mind is if there are two aldehydes, both aldehydes will react to make a diol. Okay. It's not like you could specifically target just one aldehyde over another. Okay. If you wanted to do work with an aldehyde or a ketone, and you wanted to use the sodium borohydride, which is a weaker reducing reagent, then you can use some type of polar solvent like methanol. So this, I'm just going to abbreviate methanol as such. And once again, you would end up with your alcohol, and here we would actually end up with 1-propanol. So how do these reducing reagents work? Well, they work because they behave sorry about that. They behave like a hydride anion. So a hydride anion would be a hydrogen with 2 electrons to be negatively charged. That's how they behave. Okay? I don't want you to need to know the mechanism, just know the reaction conditions. Now, just to repeat, the lithium aluminum hydride, you cannot use it around water because it would react with the water. Okay? And so that's, hopefully you've learned now a little bit about how to make alcohols using reducing reagents, either hydrogen in presence of platinum and palladium, or one of the hydride reagents like sodium borohydride or lithium aluminum hydride. We'll discuss thiols in another lecture.